So let's begin this video by reviewing, even before 8.6, there was factoring out the GCF, right? That was the very first method that we learned how to do. Let me come up with a problem. So there's a polynomial, a fifth degree polynomial, and there's three terms. I guess I could say it's a fifth degree trinomial. And if I wanted to pull out the GCF, what would it be? What's in common in all three terms? 2 and x. Is it just 2x?
2x squared.
2x squared. Remember, the GCF represents the greatest common factor. So when you look at the coefficients, like the 4, the 8, and the 2, you know you could pull out a 2. And when you look that there's x here, x there, you know you could pull out an x. But you need to determine what's the greatest amount of x's you could pull out. Right here there's 5, right here there's 2, right here there's 4. So the greatest that you could pull out from all three terms is 2 of them. So you can pull out 2 of them from all three terms. So the GCF is 2x squared. Now once you know your GCF, it's kind of like working backwards with distributive property. 2x squared times what would give you that answer, 4x to the fifth? 2x to the third, okay. And then the next one, 2x squared times what gets you a negative 8x squared?
Negative 4.
Just a negative 4, just a minus 4, right? No x's. And then over here, 2x squared times what gets you a negative 2x to the fourth? Negative 1x squared. That's right. And that's what GCF is. And that's going to be a significant part of our quiz tomorrow, right? We need to know how to factor out the GCF always. And this was the first method of factoring that we learned. This is the first type of factoring that you should always attempt. Don't jump to factoring by group. Always try to look at your polynomial and see if you can pull out anything. Because maybe by pulling out this, you're going to be able to do something a lot easier on the inside. Okay, so that was 8.5, and I didn't put it on the notes, but I mean, now you have it. That's 8.5. Let's move on to these notes, 8.6 and 7. And on 8.6 and 7, we started dealing with factoring standard form quadratic trinomials. So we first need to know, what is a standard form quadratic trinomial? It's ax squared plus bx plus c, which is your constant. And remember, a, b, and c are just numbers. Okay. And we know a super easy way of factoring standard form quadratic trinomials when the a value is 1. It says right here when a is 1. So here's an example of a standard form quadratic trinomial where the a value is 1. Let me zoom in. So again, the a value is 1. What's the c value?
1.
What's the c value?
Negative 12.
-12. What's the b value? -4. Again, a, b, and c are just numbers. Now, the beauty of factoring a standard form quadratic trinomial when your a value is 1 is that you could jump right into this format. And we know that's what our answer is going to look like. And the beauty part is, because there is no number, we know that x times x will give you the x squared, right? And from here, all we have to do is think, what times what is the c value, -12, that if I combine together is the b value, -4. And if you're confused with that, you could, if you don't see it right off the bat, make a list. And I always suggest with starting with 1 or -1, like -1 times 12, then try -2, -2 times 6, -3, -3 times 4, and that's it. Those are all the possible ways of multiplying to get -12 as an answer, besides changing the signs. So the question is, which of those pairs of numbers combines together to give us the b value, which is -4?
Negative 6.
Okay, so it's these numbers, but with the different signs, right? You have the right numbers, we just have the wrong signs. So it will be a +2 times a -6. This is the pair of numbers that we want. And we simply plug it right into our answer format, and we're done. I mean, that's the easiest part of this entire section, right? I even think even easier than pulling out a GCF, right? We should all love factoring quadratic trinomials that have the a value 1. So let me ask you a question. Are we able to factor every single quadratic trinomial that has an a value 1? No, because sometimes they're not factorable. And you could write not factorable, or you could write prime. Okay, anyway. We should love when we see standard form quadratic trinomials with no number right here because a value is 1. That means we could jump right into the answer and just think what times what is c, that if we combine together is b. Now we have this other longer, miserable, multi-step process of factoring by grouping, and that's only when your a value is not 1. Right? If you have a 2 right here, you have to use this long process. If you have a 3, a 4, any number that's out here in the front, you have to use the longer process because, like let's say for example, we had 3x squared plus 8x plus 4 and we're trying to factor it. You can't jump into the other method of x times x because x times x is not 3x squared, right? So whenever there's a number right here, you have to use this long, nasty process. So instead of just randomly doing that question, let me jump to the homework that we actually have today. And let me do one of these. Let's take a look at number 1. Now, this is a great problem because should I jump right into this factoring with all these multi-step parts?
No,
No, I should not. Why not?
because there's a number that fits.
Because there's a number in common in all the terms. Now remember, the very first method of factoring that we learned was factoring out the GCF. So you should always start by trying to factor out a GCF. Okay? So let me take this guy and factor out a GCF. What is a GCF? What could I pull out?
2.
There you go. And if I pull out a 2, what's left on the inside?
B squared plus 5a plus 6.
And this is a great example of how important it is to pull out a GCF, because if we do pull out that 2, and now we look at the inside of the parentheses, we no longer have a number in front of the b squared. In other words, our a value is now 1, which means that we could use that shortcut, put the b right there and the b right there, because b times b is b squared. So we could set this up and then just think, what times what is 6? That if I combine together is 5. 2 times 3, right? Positive 2 times positive 3. And we factored without doing the long method. Let's not forget about the outside 2. Let me bring that down. You have to put that down right there. And that is your factored form of number 1 on your homework. So that's a great problem because it shows how important it is to pull out the GCF first, right? If not, you'd be stuck with a multi-step process, which would get ugly. And I don't even think you could get to the right answer without pulling out the GCF first. Anyways, jump to number 2. Now, on number 2, I am going to use the notes that I have right here. So I'm going to first multiply a times c to get a number. So let me do that. Number 2, step 1, multiply a times c. What do I get when I multiply a times c? 12. Okay. And now I need to think of the multiples. Step 2, think of the multiples of 12 that combine together to give me the b value. I recommend always just start with 1. 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Okay? And now we need to think which pair of numbers combines together to give us the b value. 2 and 6. So this step 3 is to rewrite your b value, 8, as 2 and 6, because after all, 2 plus 6 is 8. But remember, it's not just 8, it's 8g. So I'm going to rewrite 8g as 2g plus 6g. So let me rewrite the whole thing. This is step 3, by the way. I have 3g squared. And then I'm going to rewrite the 8g as positive 2g plus 6g. Because after all, 2g plus 6g is 8g. And what about the c value of 4? I just simply bring that plus 4 down. Now, the whole purpose of converting the 3 terms to 4 terms, and notice I left space between it, is to factor by grouping. Are you with me?
Yeah.
So let's take that first group and let's factor out whatever's in common in the first group. What's in common? G. And that's it. So if I pull out a g, what's on the inside?
3.
3g plus 2. Okay. And then how about the second group? What could I pull out? A positive 2. Okay. And what's left on the inside? 3g plus 2 also. And that's great because we have a 3g plus 2 here. We have a 3g plus 2 here. So we're going to take these guys and pull them out and write it as one term out here in the front. We're going to factor out the 3g plus 2. And of course, if we did pull out the 3g plus 2 from both, this g is left over and this 2 is left over. So what I have left on the inside of my parentheses is a g, the g, and the plus 2. So I have a g plus 2 right here. So of course, let me rewrite that with the correct form or correct size parentheses. And there's my answer, my factored form. Now, what I'm about to do right now is teach you a different method on solving this quadratic trinomial that has a 3 out here in the front. I'll teach you a different method. It's very similar, but it's a lot faster, a lot easier. If you like factoring by grouping and you don't want to pay attention to me, that's fine. But if you pay attention to what I'm about to explain, you're going to be able to do this at least twice as fast, maybe even 3 times faster. All right? So what I'm going to do is I'm going to copy down number 2 again and then do it again with this different method. So here we go. Let me, I copied number 2. I want to move this to the side. And I want to move down to our notes down here where it says alternative to factoring by parts, by grouping. So this is going to be a different method to factoring by grouping. Now, step 1 is exactly the same. Step 2 is exactly the same. Step 3 and 4 are a little different, and you're going to appreciate it. Check it out. Step 1, multiply a times c. And a times c, we already know, is what? 12. Step 2, think of the multiples of 12 that combine together to give you the middle value, 8. So I have 1 times 12, 2 times 6, 3 times 4. Which pair of numbers combines together to give us 8?
2 and 6.
2 and 6. Okay, so here's the new part. Step 3. It says plug in that pair of numbers from step 2, the 2 and the 6. Plug it in where? Into this answer format. Parenthesis AX, parenthesis AX. With space right here. Now, this is just really weird. Let me show you. Step 3 is going to jump straight into your answer format. And I'm going to plug in an AX. Now, what is my A value on number 2? What's my A value on number 2? 3. Okay, so instead of 3X, it's a 3G and 3G. Now, why is this weird? Because this doesn't really make sense, because 3G times 3G is what?
9G.
It's 9G squared, not 3G squared, right? So this is really weird, but later on we're going to adjust it to get rid of one of these 3's, okay? Check it out. Anyways, going back to step 3, plug in that pair of numbers from step 2 right into here and here. So I need to take the 2 and the 6, and I'm going to take the 2 and plug it in right here, and the 6 and plug it in right there. So I'm going to plug in my 2 right here, as in positive 2, plug in my positive 6 right here. And now step 4. Check out step 4. It says reduce each binomial. Okay, this is a little weird. By dividing it by its GCF if possible. So in my first group, do I have a GCF? No. My second group, do I have a GCF? Yes. So it's kind of like if it were a fraction, you want to reduce it by that GCF. So we're reducing it by 3. So I'm going to put a little division sign 3, division sign 3. And that will modify my second binomial to become what? What's 3 divided by 3? 1. So you just have 1g. And what's 6 divided by 3? 2. So you just have plus 2. And that first binomial, we weren't able to pull out a GCF or reduce it by a GCF. So it's still 3g plus 2. Now, if you check on the work that we just did, it's the same exact answer. It's just done way faster. Now, right here, it took a while because I was explaining in detail every single step. But let's take a look at another one. Let's do another one with this short method. So on the worksheet, we're going to take a look at number 3. What's the A value on number 3?
4.
And the C value? Negative 3, okay. So let's, again, step 1 and step 2 are the same as what we learned before by grouping. Still, step 1, A times C. What is A times C? Close? Negative 12. That is A times C. Now, step 2 is to think of the multiples of that number that combine together to give you 4. I recommend making a list. Negative 1 times 12, negative 2 times 6, negative 3 times 4. Which pair of numbers combines together to give us a positive 4? This negative 2 and the positive 6, right? Now, step 3, write your answer format as AX times AX with space, right? So what's my A value? 4 with an X, 4 with an X. Now, again, this is weird because 4X times 4X is not 4X squared, it's 16X squared. So we know that we're going to have to reduce, we're going to have to get rid of one of these extra 4s, okay, in some sort of way or other. Now, we take these pair of numbers and simply plug them in, all right? So we're going to take this negative 2, put it right here, take this 6, put it right there. So the negative 2 goes right here, and the positive 6 goes over here. Step 4 is to reduce your binomials, each one of them, by each of its GCF. So what is the GCF on the first binomial? 2. So if we reduce by 2, divide by 2, divide by 2, what do we get?
2x
minus 1, okay. And then reduce the second one by its GCF. What's the GCF on the second binomial? 2 as well, right? So what we have left is a 2x and a plus 3. Now, this is our answer. We're done. For real. For real, yo. No. But seriously, it's so much easier to do it this way, so much faster to do it this way. Now, I know if you're thinking, well, what? This is weird, dividing by 2. Think about it, guys. When we set up 4x times 4x, that was 16x squared, not 4x squared. So we know that we needed to get rid of the multiple of 4, right? So when we divided the first binomial, what did we divide by? By 2. What did we divide the second binomial by? By 2. And 2 times 2 really is that extra 4 that we had, if that makes sense. But if you follow the steps, you should be able to get to the answer a lot quicker, way faster than factoring by grouping. It's totally up to you. Now, I'll tell you this, in Algebra 2, in pre-calc, you're going to need factoring by grouping. So it's great to continue practicing factoring by grouping. But if you're concerned about getting a better grade tomorrow, being able to finish the quiz faster tomorrow, this is definitely the better option for you to practice this method right here. So we have the entire worksheet of, what is this, 8.7 WSP. You could practice with this shortcut method. Good luck. Remember, questions on the quiz come straight from the homework.